We are Volunteer Computing, and our project is based on setting up a BOINC server so that we can provide a lot of computing power to the different researchers, specifically to Dr. Valente. I'm Chris. There's also Dave, two Brians, and a Jack that helped us, that all did this wonderful work here. So our case for change is just that, like I said, that we are trying to develop this server backbone so that we can farm out massive amounts of work to a bunch of computers, hopefully, and it'll get done a lot faster. Dave here can talk to you about BOINC.
The main use behind our project is the Berkeley Open Interface for Network Computing. It is a server and client package that will take in compiled code into its server and then pass it out to other clients that are connected. Those clients that are connected will run the code that they're given and send the results back. A little history behind BOINC. It was created at Berkeley for use in improving security with the SETI at Home project, which is searching for extraterrestrial life. And now here's Jack talking a little more about our architecture.
To start our project, we used the BOINC system that was just talked about, but on top of that, we made it more simple to use and install by packaging it into a Debian package. BOINC documentation suggests 3 months to set up the server and get a project running. With our package, which is stored in Google Code as a Debian package, you can now install a server and have it set up in approximately 10 minutes with no experience in packaging or Debian or even coding. Once the package is installed on the server, all of your web interfaces and all of the scripting and coding that we did is available for creating projects and adding work. Through the web interface, once the package is installed, you can submit your MATLAB code. Once submitted, that MATLAB code is transferred using secure SSH keys to a separate server which compiles the MATLAB code, and the code is then sent back to the server, which finishes putting in place the project and setting up all the web interfaces that are specific to that project. Once that's finished, then you can attach clients, which are individual computers, to the server and give the server work units to do. Those work units are then sent out to each of the computers that were attached to the server. The code is processed and the results are returned to the server, which is then accessible through the web interfaces. That's the basic idea. You just set it up, give it some code, it processes the code, and you get your results back without any coding or any expertise in server management or packaging or anything. Everything's done through the web interface. And we'll talk about a little bit more about the web interfaces.
Alright, we wanted to make it very easy to administer without having to go into the BOINC internals, so we made a lot of web interfaces. One of them was for project creation. You just give a MATLAB file and a project name that will create your project so that it can be run by BOINC. We also have another interface to create work units, which are the units of the computation that is done and farmed out. BOINC already includes some facilities to register users and see how much work is being done, but we improved on those also. And then we also added an interface to show the results once they are collected back from the users. Now I'll have Brian talk about MATLAB.
For our project, we need to come up with a simulation to run on our system that will require a fair amount of processing power. We decided to go with a Monte Carlo simulation, which would run lots of random numbers, 50 million in our case, and return the results. The reason we did this is because you could have a single machine that would run, 200 million times, which would take a fair amount of times, where you could have 4 machines in our system run each 50 million times and return the results a lot quicker. So that was kind of the basic reason for going with a Monte Carlo simulation. Just a lot of number crunching and returning the results of the mean, standard deviation, median numbers. So that's basically our simulation that we wanted to run.
Derek, I was going to tell you a little bit about one of the nice aspects is all the users have a client that they have on their computer, And with that client, it allows them to interact with our services, which they can specify when they want their computer to accept jobs from the server, and like how much hard drive space they prefer to allow for the server to use, and how much computer processing percentage that they'd allow. You can also set up frames for certain times of day that you want it to run, like maybe if you only wanted to run in the evening. Or you can also set it up to run during idle, like after your computer's been idle for so many minutes. And what the client also does is it looks for jobs, and once it sees that the jobs are available, it will accept the work units, which are accepted onto the computer, and then your computer then processes them, and then the client then ships them back to the server so they can be collected.